In this video we're going to look at this relay module that I got. So I have the spacers here that I bought separately. They did not come with the unit. The spacers do not fit in the top here, which is a bummer there. So I kind of have to unscrew it there. But I have to kind of put it in at an angle. There's no way to twist this. And if I push hard, maybe it will go down. And then I can put the female spacer down there. But for now, I'm just going to set them like this. But I would have to like glue them or solder them or something to make them more permanent right there. But in any case, that's enough about the spacers. They're extra. There are a lot of pins down there that I don't want to make a direct connection. So I'm elevating them a little bit with these spacers. Now, the power supply here, I have my bench power supply set to 5 volts. So I could use the breadboard power supply for this demonstration, no problem. 5 volts right there. I limited the current from the power supply. So never measure current from the power supply, but I'm going to right now because I know the current is limited. So if you measure the current of a power supply, which you shouldn't do, but if current is limited, and I don't know why we're not getting any current. There we go. I just didn't have a good connection, I guess. So I set it to 500 milliamps of current, and that's what we have. So, and you might have heard the power supply click when I either made or released a connection. So we're going to power the unit here. Let's get the meter off of measuring current right now. It's a good idea to always do that. So you can see here that we have, see how close we can get. That's about as close as I can get before it turns blurry. So you can see ground on the left and then VCC on the right. So I'm going to plug the positive there, or on top, VCC on top. And this is a male to a female jumper. So this is female, we put it there, and then we do the same thing with the ground. We have to power this right there, and then go to negative. And so now, what we're going to do is, you can see here we have 2 pins there. So that's input 1, the lower one. Input 2 is the more upper one right now. And so that's the 1 relay, and that is the 2 relay. And it already has the diode for the voltage kickback and whatnot. All we have to do is provide a signal. So again, I'm going to set this to milliamps. We already know that the power supply is set to no more than 500 milliamps. So this can go up to 500 milliamps at that setting. Perfectly fine, worst case scenario. And what I'm going to do is complete the current through the meter. So these pins are activated by a low signal. So I'm just going to touch the one, and you can see it went up there. There's an LED that's on, and let's do this one. Right there, you can see that LED turn on when it clicks. So we are switching the relay. Let's see if I can turn it so we see that LED with that one there. So I have 3 milliamps of current, or 4 milliamps of current it looks like, going through the meter, and we have to give it a low signal. If we give it a high signal, nothing happens. So we got to connect it to ground. And I'm not sure the exact voltage above 0 volts, but close to 0 volts. So in any case, that is how this works right there. So now let's look at what it actually does. So now I screwed down jumpers, a red one, and a blue one in the middle. As you can see here, there's the same lines drawn out on there. But what this is telling you is that this is a normally closed switch. When nothing's going on, that switch is closed. this one is a normally open switch between those two pins there. So when we give a signal, this line moves from one to the other, and it stays there as long as we have that signal. So one side is normally closed, so we will wire that up right now. I'll just put this jumper, the blue one, to the negative rail, and this jumper to the LED right there, and I even bumped the other one. You saw that turn on. That LED is on. So now we're going to take this jumper here, and this is wired the same. We will plug it in there. So this is a 1 kilo ohm resistor and an LED in series. Of course, the LED is polarized. The long lead, the anode, needs to be towards the positive side of the power supply. So we're going to connect that to the resistor. Short lead, the cathode, we're going to go down one row right there. And we are done. So you can see this LED is on. As I said, the right two, there's a second relay, so we can look at this one. It's not being blocked. The right two are normally closed, and then the left two are normally open. Normally open. Open means off. So let's zoom back a little bit. What I'm going to do now is take this alligator clip that I crimped to a jumper and plug the jumper to the negative rail right there, and now I can connect to that pin that we had before, and you should be able to see an LED light up, I think. Yeah, there's the LED that lights up. So you can see when I make the connection, I give the low signal to that pin, then the relay is switched, and so it switches so that the normally closed switch is now open, and the normally open switch is closed when it is switched, and then we release it. It goes back to its normal state. And of course, you don't have to use both of these. We would have to unscrew it. I'm just going to yank the jumper, but if you just want the load to be off until you get a low signal, and I pulled that jumper off. There you go. But if that's what you want, that's fine. You can do that, as you can see there. Or if you want it on, just want it on until you get a low signal so that you turn it off, you can do that too. That is no problem right there. So now, another thing. When we measured current at the beginning, we looked, it took about 4 milliamps of current to switch this. We saw that. We provided that at the input. We also have these power pins too. Of course, they're going to provide power. We're going to look at that coming up, how much current goes through here. But the current that goes through this part, all this is a switch as far as the current is concerned here. And so we actually can use two separate power supplies. We don't have to use the same one, and we can use a weak power supply over here. All we need is 5 volts really, and we can use I think it's 30 volts DC up to 10 amps, or 200 and looks like 15 volts AC up to 10 amps. It can switch that according to what's written here. And so these are separate. Right now the power is going from positive rail through the resistor, through the LED, through that jumper, over to here, and to ground. None of this power affects that at all. As I said, we could use two separate power supplies. So now we're going to measure how much power it actually takes to run the relay. And so we have this here. We can actually measure the two of them. So this wire here is what's going to power the relay to switch states. So I have an alligator clip that is temporarily clipping the black probe there, right there, and let's go up to milliamps. Again, we have the power supply set to only 500 milliamps, so we really don't have to worry about too much current for this meter. So let's go up here, and the red probe, so this goes to the positive side of the power supply. We went to the black probe. The red probe is what we're going to use to connect to the power supply. So there you can see that the relays aren't doing anything. We just gave them power, as you can see up there. So now I'm going to take the jumper there and switch the relay, one of the relays. There we go. And you can see it's about 60 milliamps of current. There we go. That's holding it better. And we can switch the other one. There you go. About 61 milliamps of current. So let's do both of them. This is wide enough to connect to both of them. There we go. So we have both of them going. Of course, it's about twice the current there. So that's how much current it takes. There's an inductor in there that moves, a magnet basically. And so right now it is pushing on one of the switches, the normally closed switch, and a magnet moves it so that it pushes and switches the other switch, and it takes current to do that. And it looks like for 5-volt relays it's going to be about 60 milliamps of current, in that range. There's 2 relays here, so having the 2 of them switch by giving a low signal to both of them with the module, then it's about 120 milliamps of current with the 2 of them while they are on. You turn them off, put them in their normal position, and it doesn't look like this module takes any current really. There may be trickle there somewhere or something, but in any case, hopefully that all made sense, and I'll try to come up with some good circuits, probably get some other relays that relay modules that operate differently, and get a feel for what all is out there, hopefully. But in any case, hope you still enjoyed the video as is. So thanks for watching. I will see you in the next video.